everybody. Welcome to part 2 of our discussion of division problem types. In part 1, we talked about how you can take a total number of kids, and then we would either measure out 4 at a time to an unknown number of cars, or we would take the 12 kids and fair share or equally part that group out to a known number of cars. So that was the measurement in partitive with whole numbers. One of the reasons why this is so valuable is when kids start learning how to divide fractions, it gives teachers some guidance on what type of context you want to give the students for what type of number sets you're working with. So we'll look at some quick examples here that really highlight why this is such important knowledge to have of division. If we take a whole number, like 4, divided by 1/3, that particular number set is actually much easier to connect to for students when they're first learning to divide fractions if we deal with a measurement example. So we're going to think of a measurement context to fit that type of number set. So one that I think might be helpful is, let's say you have a bucket that has 4 gallons of water in it, and I'm going to draw a quick bar model here. Okay, so I'm drawing 4 units of 1 to represent the 4 gallons. And then let's say there's a hole in the bucket, so it's leaking about 1/3 of a gallon every minute. And what we have to figure out is how many minutes will it take for the whole bucket to be completely emptied if it leaks out 1/3 of a gallon every minute. One way to model this would be to just look at each unit of 1 and partition those into thirds. And then we can kind of work our way across here that we have 1/3, that's 1 minute, 2/3, 3/3, going all the way across to where we find out that there are 12 1/3s to compose 4. So you have 12 1/3 units to make up that 4. So that's a measurement idea, because what you're basically finding is how many 1/3s compose 4. So if I measure out 1/3, how many will it take to get to 4? Trying to think of this as a partitive, which is that fair sharing, where the groups are known but the measure of the group isn't known, is kind of difficult. There are some ways to do it, but that conversation is better left for discussions of ratio and proportion in the middle grades. So again, this is when kids are first learning this idea. So it's difficult to think of sharing to 1/3 of a group. That doesn't really make a lot of sense, and it's difficult to model as well. But again, there are ways to make it work, but we'll talk about that later with some middle grades ratio proportion. So if we were to change our number set now, and we're going to talk about 1/3 divided by 4, now that partitive division type is so valuable because it makes a lot more sense to think of taking 1/3 and fair sharing it into 4 equal parts, or partition it into 4 equal groups. So I'll draw a diagram to represent this idea. So we're going to just take a unit of 1, and I'm going to show that I have 1/3. I'll just lightly shade that in. So there's my 1/3. And let's go back to the context of water. So let's say there's just 1/3 of a gallon of water, and it needs to be fair shared to 4 containers equally. So what we're going to do here is we're going to take that 1/3 of a gallon, and we're going to partition it into 4 equal parts. Now here's a really important thing that happens when you get to take a fraction and divide it by a whole number, is the reason I actually built out to the unit of 1 when I started was because it becomes really difficult to name how much is in each container. As I took that 1/3 of a gallon and I equally partitioned it out to 4 containers, it's hard to name that now, because what my model basically says is it's 1/4 of a third. So to name it, we can go to each 1/3 unit here, partition them into 4 equal parts, And then if you actually count up how many units it takes to compose one, it's now in twelfths. And so that is why 1/3 divided by 4 equals 1/12. Because what this is answering is, what is the size that you create of whatever unit or part if you take 1/3 and equally share it into 4 equal parts. So that's why measurement and partitive division are so valuable for later learning, because they help make something that is actually pretty difficult for kids to really tackle the first time they learn it, gives teachers access to some ideas on how you can give story problems that make a little more sense and give kids a better entry point in terms of modeling and solving the problems. Okay, I hope this was a helpful discussion, and we're going to do some more videos on how to use some different techniques and methods with division that will actually work with some more complex number sets that build off this idea.